Assalamualaikum and hi everyone. Today we are going to learn chapter 4, multiple integrals. So in this video I will cover subtopic 4.1, area in polar coordinates. Okay. So if you refer to your module, you may turn to page 215. Page 215. So we have area in polar coordinates. Alright, I have prepared some slides for you. Okay, so let us recall what we already learned in chapter 1 in subtopic of polar coordinates. So we have learned a few formulas to convert from rectangular coordinates to polar coordinates and vice versa. So we have formula of x equals to r cos theta, y equals to r sin theta, r squared equals to x squared plus y squared, and tangent theta equals to y over x. We also learn about how to sketch sum of graphs in polar coordinates. We have here r equals to a sin theta, and then we have r equals to a cos theta like this. Please bear in mind when we have sine, so the graph would be symmetric about y-axis, and when we have cos, the graph symmetric to the x-axis. And then this is we call it as cardioid. Okay, this is cardioid. R equals to a plus a cos theta. The value here and here would be the same. Okay. Next, we also have roses. Okay, so we already learned how to sketch roses in the chapter 1. Okay, so now let us move to the formula of area in polar coordinates. We have A denotes as area. Integration from A to B. Okay, integration from A to B, where A is actually the angle. Okay. So we have theta is from A until B. Alright. And then we have formula of 1 over 2 multiplied by r squared d theta. So this is the formula of calculating the area in polar coordinates. So let's take a look at example 1. Find the area of any two petals of the rose r equals to 6 cos 3 theta. Okay, so let us solve this equation. Example 1. Area of r equals to 6 cos 3 theta. So first of all, let us sketch the rose curve. So we have this. So since we have 3 means we have 3 petals. And this is the length of petals. So our rose curve would be something looks like this. Okay, so here should be 6. Alright, now the question asks you to find the area of any two petals. Okay, any two petals. So we need to find the angle for one petal. Okay, so find the angle. Alright, so what we should do in order to find the angle is we let actually this method is specifically for rose curve. Okay, so we let r equals to 0. So we have 6 cos 3 theta equals to 0. Okay, so we have cos 3 theta equals to 0. So 3 theta is equivalent to arc cos 3 theta. Oh, sorry. arc cos 0. So we have 3 theta equals to pi over 2. Then theta equals to pi over 6. So where is the location of this angle? We will have the angle right here. Okay, this is theta equals to pi over 6. So since this is the curve for cos, means that this graph is actually symmetric to x-axis. Okay, so when we say that this curve is symmetric to x-axis, therefore we also have another angle here, which is equivalent to negative pi over 6. So guys, what we can do here now is we can calculate the area of this petal. Okay, so therefore let us use the formula here. The area equals to 1 over 2 integration from a to b of r squared d theta. So we have 1 over 2 integration from, as we can see in this graph, theta from negative pi over 6. So from negative pi over 6 until pi over 6, r squared, our r is 6 cos 3 theta. So we have 6 cos 3 theta squared d theta. Alright. Or actually guys, alternative method, we can also find the area by considering the angle from theta equals to 0. Okay, you can consider from theta equals to 0. So when you can consider from theta equals to 0 until pi over 6, it means that you have to multiply by 2. Okay, so we have the formula 1 over 2 multiplied by 2, because we consider angle from 0 until pi over 6, and then we have 6 cos 3 theta squared d theta. Alright, so you can use either one of these two formulas. Okay, so now let's say I use the second formula. I use this. So the question asks you to calculate 2 petals, right? So 2 petals. The area for 2 petals. The area for 2 petals. We have 2 petals. Multiply by 1 over 2, multiply by 2, multiply by 0 until pi over 6. So 6 cos 3 theta squared d theta. Because the area for each petal will be the same. So that's why in order to calculate the area for 2 petals, we just multiply by 2 petals. So now we can cancel these 2 and these 2. So we will have, let us proceed with the integration. So we have equals to 2 petals multiplied by integration from 0 until pi over 6. 6 cos 3 theta squared is equivalent to 36 cos squared 3 theta d theta. Okay, so 36 multiplied by 2, we have 72, 0 until pi over 6, cos squared 3 theta d theta. So in order to solve this integration, we should use the double angle formula. Okay, use double angle formula. Okay, in double angle formula state that when we have cos squared theta means equivalent to 1 over 2 1 plus cos 2 theta. So in this case, what we can do here is equals to 72 integration from 0 until pi over 6. So we need to change. Okay, we need to change here. Cos squared equals to 1 over 2. We have 1 plus cos. Alright guys, let me explain to you about this. When we have theta, means 2 theta. Okay, so in this case, we have, in the equation, we have 3 theta. So in order to use the double angle formula, 3 theta will becomes into 6 theta. Okay, you have to multiply by 2. So d theta. Alright, so now we can proceed with the integration. This is equivalent to 72 times half, so we get 36. 36, so integration of 0 until pi over 6, we have 1 plus cos 6 theta d theta. So now equivalent to 36. Integrate 1, we get theta. And then integrate cos 6 theta equals to sine 6 theta divided by 6. So substitute 0 and pi over 6. So we will have 36 multiplied by pi over 6 plus sine 6 times pi over 6 is sine pi. Okay, over 6. Minus, substitute 0, so theta equals to 0, plus sine 0 is 0. Okay, and then we have sine pi also 0. So finally, we will have 36 multiplied by pi over 6. So the answer would be 6 pi. That's it. Okay, finish already for example number 1. So now let us proceed to example number 2. Okay, example number 2. It said that sketch and shade the area of the region bounded in the first and second quadrant of the given equation. Okay, so this is actually a cardioid. Okay, a cardioid. On which axis? Since this is cos, so it must be on x-axis. Okay, so let us solve example 2. So we have a cardioid. R equals to 4 minus 4 cos theta. Okay, so let us sketch this cardioid. Alright, 4 minus 4 cos theta, so it will be looks like this. Here should be 4, right here should be negative 4, and here should be negative 8. Okay, and the question asks you to find the area in the first and second quadrant. So first and second quadrant. Okay, for the case of cardioid, we can simply take the angle from the graph. So no need for us to calculate the angle whatsoever. We just can take the angle directly from this graph. So here, from this point, the angle equals to 0. And then until this point, the angle here is pi. Okay, so therefore, the area A equals to 1 over 2 integration from 0 until pi. we have 4 minus 4 cos theta squared d theta. Okay, now let us solve this. So 1 over 2, let us expand this formula. So we have 4 squared is 16. 2 times 4 times 4. So negative here. So we put negative. 2 times 4 is 8. 8 times 4 is 32. So minus 32 cos theta. And then we squared the second term. So we have positive 16 cos squared theta d theta. Okay guys, now again, we have cos squared here. So we should use the double angle. Okay, use double angle formula. So we have 1 cos squared theta equals to 1 over 2, 1 plus cos 2 theta. Okay, so now we can proceed this integration. Okay, multiply everything by half. We will have 0 until pi, 8 minus 32, sorry. 32 divided by 2 is 16 cos theta plus 8. 16 divided by half is 8. So convert cos squared theta, it becomes 1 over 2, 1 plus cos 2 theta. Okay, so we will have, let us expand this. So 8 minus 16 cos theta plus 4 plus 4 cos 2 theta d theta. Okay, so 8 plus 4 should be 12. So we have 0 until pi, 12 minus 16 cos theta plus 4 cos 2 theta d theta. So let us integrate this. We have 12 integrate with respect to theta, we will get 12 theta. Integrate negative 16 cos theta equals to negative 16 sin theta. Integrate 4 cos 2 theta, we will get 4 sin 2 theta over 2. So substitute 0 and pi. Then we will get 12 pi minus 16 sin pi plus, okay, so this can be cancelled. This is 2, this is 1. So we have 2 sin 2 times pi, so sin 2 pi. Minus, substitute everything with 0, every theta with 0, so we will get 0 minus sin 0 is 0, sin 2 0 also 0. Okay, so finally, alright guys, what we get here is sin pi equals to 0, sin 2 pi also 0. So finally we will get 12 pi. That's it. Done. Okay, next. Look at example 3. Okay. Find the area of the region that is inside of the circle r equals to 8 sin theta and outside of the circle r equals to 4. So this question is quite interesting. So let us sketch the region first. Okay. So inside the circle, example 3. Okay, inside circle r equals to 8 sin theta, and then outside circle r equals to 4. So let us combine these two graphs. Okay, so we have something looks like this. So first of all, r equals to 8 sine theta. Okay, r equals to 8 sine theta. We have this circle. Here should be 8. And then another one we have r equals to 4. So r equals to 4 is like this. R equals to 4. So here should be 4. Here also 4, negative 4, negative 4. Okay. So let us shade the region. It said that inside the circle and inside the circle of r equals to 8 sine theta. So this is r equals to 8 sine theta, and here is r equals to 4. So inside here and outside r equals to 4. So this is the region. Okay. Now, what you should do here is you need to find the intersecting angle. Okay, the intersecting angle means that the angle of intersection between r equals to 8 sine theta and r equals to 4. So the location of the intersecting angle should be here. Okay, so we need to find the angle of intersection here. So we need to find what is the angle. Okay. So in order to find the intersecting angle is you have to equate both r1 equals to r2. So r1 is 8 sine theta and r2 is 4. Okay, so 8 sine theta equals to 4, therefore we have sine theta equals to 4 over 8. Sine theta equals to 1 over 2. Theta equals to arcsine of 1 over 2, therefore theta equals to 30 degrees or equals to pi over 6. Okay guys, so here theta equals to pi over 6. Since theta 1 equals to pi over 6, therefore theta 2 should be equals to 5 pi over 6. 5 pi over 6. So how do we get the theta 2? Okay, so this is theta 1. Theta 2 is pi minus pi over 6. So we have 5 pi over 6. Okay, now let us calculate the area. Equals to 1 over 2, integration from pi over 6 until 5 pi over 6. Okay guys, in this question, since we have 2r, what we do is the first r should be minus to the second r. Okay, so we have 8 sine theta squared minus 4 squared d theta. Okay, so 8 sine theta squared minus 4 squared. Or you can also have alternative method. If we consider the angle up here. Okay, if we consider from pi over 6 until theta equals to pi over 2 until up here, so we can have the first and second, the first region and the second region, right? So now the alternative method, we get this equals to, we need to multiply by 2, so times half, so the difference is the angle. So we start from pi over 6 until pi over 2. okay, because we consider the region from this to this. Okay, so since this graph is symmetric about y-axis, therefore the first region should be the same as the second region. That's why we can consider data from pi over 6 until pi over 2. So it's up to you. You can use the first formula or the second formula. Okay, so we have 8 sine squared minus 4 squared d theta. Okay, let me use the second formula. So I will have, this can be cancelled, then I will get pi over 6 until pi over 2, 8 sine theta, 8 squared is 64. Sine squared theta minus 16 d theta. Okay. Again, we need to use the double angle formula for sine squared theta. So just now for cos squared we have 1 plus cos 2 theta, but for sine squared equals to 1 over 2, 1 minus cos 2 theta. Okay, so for sine squared we have 1 over 2 multiplied by 1 minus cos 2 theta. So let us proceed with the integration from pi over 6 until pi over 2. 64 times half 1 minus cos 2 theta minus 16 d theta. So equals to 64 times half should be 32. 32 minus 32 cos 2 theta and then minus 16 d theta. So 32 minus 16 should be 16. Minus 32 cos 2 theta. So now we can integrate this easily. We have integrate 16, we get 16 theta. Integrate 32 cos 2 theta, we will get negative 32 over 2 sine 2 theta. Okay? Because we have 2 here. So that's why we need to divide by 2. Okay. So close this and substitute the angle pi over 6 and pi over 2. So we will have 16 multiplied by pi over 2 is 8 pi. So we have minus 16 sine 2 times pi over 2 is sine pi. Okay, minus 16 multiplied by pi over 6. So we will have 8 pi over 3 minus 16 sine 2 pi. 2 times pi over 6 is sine pi over 3. Alright, so now sine pi is 0. Sine pi over 3 should be square root 3 over 2. Okay, so we will have 8 pi minus 8 pi over 3. We should get 16 pi over 3 plus, so 16 times square root 3 over 2, we have plus 8 square root 3. Okay, so that's it. This is the answer. Done. Okay, next, let us take a look at example number 4. Find the area of the common region. Okay, the common region enclosed by the circles r equals to 3 sine theta and r equals to 3 cos theta. Okay, so now Okay. Let us solve this question. Common region, okay, common region. So example 4. Common region of number 1, r equals to 3 sine theta, and number 2, r equals to 3 cos theta. Okay, so let us sketch the graph. We have, first we have 3 sine theta. So this is the graph for 3 sine theta. So of course right here should be 3. And then the second, let me use the blue color. R equals to 3 cos theta. So the circle would be here, guys. Okay. Should be like this. Here is 3. Okay, so now the common region should be here. Am I right? Okay, so we need to find the area of the common region between r equals to 3 cos theta and then r equals to, r equals to 3 sine theta and then r equals to 3 cos theta. So what you should do here is you need to find the intersecting angle here. Okay, we need to find the intersecting angle. So what is theta? Okay, so again, in order to find the intersecting angle, we need to equate R1 with R2. So we have 3 sine theta equals to 3 cos theta. Okay, so we have sine divided by cos equals to 3 divided by 3 is 1. Okay, so this is tangent theta equals to 1. Therefore, theta should be equals to arctangent of 1. So theta equals to 45 degrees or pi over 4. Okay, now we know that here theta equals to pi over 4. Okay, so on the x-axis we have theta equals to 0, and on y-axis we have theta equals to pi over 2, right? So in this case we can calculate the area of the region like this. Okay, we have the first part here, and we also have the second part. Let me use the orange color, the second part here. Okay, so for the first part, okay, area equals to 1 over 2 integration from 0 until pi over 4. Okay, so from 0 until pi over 4, 0 until pi over 4, the line involved is this line. Okay, the line here involved is this line. So this line belongs to r equals to 3 sine theta. Okay, this line, the lower line. So we have 3 sine theta squared d theta plus, for the second part, integration is from pi over 4 until pi over 2. Okay, so we have first part and second part. So from pi over 4 until pi over 2. Okay, the line involved from pi over 4 until pi over 2. Let me rub this first. So from pi over 4 until pi over 2, the line here, the blue color here, is belongs to r equals to 3 cos theta. Okay, so we have from pi over 2 until pi, 3 cos theta squared d theta. Or alternatively, okay guys, actually this graph and this graph are the same size. Okay, the region is actually symmetric on theta equals to pi over 4. Alright, so we can just calculate one part and then multiply by 2. So for the alternative calculation, we have area equals to 2 times 1 over 2. We can just consider the first part, so 0 until pi over 4, 3 sine theta squared d theta. Okay, so let us solve this. So I can cancel this one. Therefore, area equals to 0 until pi over 4. 3 sine theta squared is 9 sine squared theta d theta. Okay, now again we need to use the double angle formula. So we have 1 over 2, 1 sine squared, so minus cos 2 theta. Okay, so we can proceed with the calculation. 0 until pi over 4, 9 multiplied by 1 over 2, 1 minus cos 2 theta d theta. So we have integration 0 until pi over 4. So 9 over 2 minus 9 over 2 cos 2 theta d theta. Okay, now integrate 9 over 2, we will get 9 over 2 theta. Integrate negative cos, we get negative sine. So negative 9. Alright, cos 2 theta. Okay, so cos 2 theta equivalents to 9 sine 2 theta over 2, so over 4. Right, so we have theta equals to 0 and pi over 4. So we will have 9 pi over 8 minus 9 over 4 sine 2 times pi over 2 is sine 2 times pi over 4 equals to pi over 2. Right, and then minus, substitute 0, so we have 0 minus 0. Of course, sine 0 is 0, right? So here, sine pi over 2 is equivalent to 1. Therefore, the answer is 9 pi over 8 minus 9 over 4. That's it. Finish. Okay, guys, so you can try all of these exercises. Okay, and the answer is already given. So all the best. That's all for today. Thank you.